materials. So it should be accurate, and the dimension should be stable. They can give good reproduction details. It is strong and also resistant to abrasion, and should be compatible with the impression material, whether you use the alginate or the elastomeric impression materials. And usually they have a color, yeah, and the color is quite the same, like blue, pink, yellow, or soft green, yeah, etc. And it should be safe, especially to the patient, to the operator, to the dentist, and also easy to use and also affordable. Okay, usually gypsum materials is affordable, especially plaster of Paris. It's very cheap. The gypsum product is usually come from the gypsum rock. It's calcium sulfate dehydrate. Yeah, this is dehydrate, so there is water here too. Yeah, calcium sulfate dehydrate. For dental gypsum, in dentistry, we usually use the calcium sulfate hemihydrate. So the two here is heat, so that we will have the only the half of the water. This is one of the reaction for the calcination. So we have here the calcium sulfate dehydrate, yeah, over here, and then we heat it, yeah, we heat it, and then we will have calcium sulfate hemihydrate. So all the 1.5 of the water is evaporating, yeah. So we will have only the calcium sulfate hemihydrate. Yeah, so usually if we put more, we mix gypsum, so we use the calcium sulfate hemihydrate and we mix with water, and the reaction will liberate heat, yeah, when it sets. So this is the exothermic reaction because of the recrystallizations of the particles of the calcium sulfate with the water. Okay, and then we have various dental gypsum, especially in dentistry. We have plaster of Paris. This is type 2. We call it sometimes beta hemihydrate, and the color is usually white. Okay, dental stone, the type 3, we call it alpha hemihydrate. Yeah, and the color is usually blue, yellow, or pink. Yeah. And then we have also the dental stones like type 3, but they have more strength. So high strength but low expansion. This is the type 4. Yeah, this is a modified of alpha hemihydrate. The color is usually pink, yellow, or soft green. Yeah, and the last one is dental stone, high strength and high thermal expansion. So if we mix, yeah, the stone will be very, very strong, but they have a high expansion than the type 4. Yeah, this is type 5, and the color is blue or green. Yeah. So different properties between all these type, they also different uses. Yeah, the plaster of Paris, usually we use it for study models, yeah, just to make clear study of the condition of the teeth, yeah. And then dental stone is for walking model. Sometimes we use this dental stone for making for carving the inlay or crown or braids, yeah. And also the dental stone high strength, yeah. But usually low expansion here, it depends on also the use of the metals that we are going to use. And then we have the dental stone high strength, high thermal expansion. Sometimes it is also used as an investment material when we are going to cast metal which have an expansion, higher expansion, so that it will be compensate with the thermal expansion of the dental stone or investment materials. Okay. Different uses of dental gypsum. I think I already explained to you. Yeah, this one. Okay. This impression plaster type 1. Yeah, this is usually not. We don't use this one again because now we have impression materials that especially for edentulous arches with the elastic impression material, it's easier to use than this impression plaster. It's very like the mixture of gypsum, and then we put it in the custom tray, and then we do the impression to the mouth, yeah. But the impression plaster is not very easy to use, yeah, and it's quite brittle. So okay. And then this one, plaster of Paris for study model. Yeah, usually the water powder ratio is 0.45. And then we have type 3, yeah, for making full or partial denture models, ortho models. And it's require higher strength and abrasive resistance. Also the dental stone of type 4. Yeah. This should need hard and resist the abrasion of sharp instrument when we are doing the carving, yeah, the wax carving. Yeah. Also the type 5. The type 5 is they have a higher strength, higher expansions, and can withstand the high temperature as high as 1,500 degrees C, which is required for the casting procedure. Yeah. It has the addition of silica to make it stronger and high expansion. Okay. So if you have question, then you just ask me anytime. Okay. This is the setting reaction. I think we already I already give you the reaction. So this is the calcium sulfate hemihydrate, only half of the water. And then if we mix with water like this, then we will have the calcium dehydrate, yeah, here, and also the heat as a exothermic reaction. Okay, this is the water powder ratio of the material. So tomorrow on Saturday you will use the gypsum, plaster of Paris. I mean no, not plaster of Paris. Dental stone that and the water powder ratio will be like this, 0.28 to 0.30. Yeah. Okay. So different particle size of the powder will cause different calcination, and also different water powder ratio. Okay, so usually the less water that we use is because the particle is smaller. The size of the particles is smaller. Yeah. Okay. For the setting time of the gypsum, if we need setting time which is slower, yeah, the setting time is higher, it means it is slower, then you do the mixing not too long, yeah, and the water powder ratio is higher, and we can also add some retarder, yeah. But for the faster setting time, we mix more longer, and water powder ratio is lower, and we can also add some accelerator, which is the potassium sulfate. Okay, so this in the right picture, you can see the water powder ratio. Okay, so if you use plaster of Paris here, you use a powder of 100 gram, then you will use the water of 45 to 50 milliliters. That's why the water powder ratio is 0.45, yeah, or 45 per 100. Okay. So how to mix? Don't forget when you are going to use this on. Oh, you have already done it, right? Last Friday, right? Yeah. Okay. So how to mix? Don't forget, you put powder first. You add water first, and then you put the powder to the water. Is that right? You do that?
Isn't it you put powder to the water first, Paul?
No, you put the water first, and then in the bowl, and then you put the powder. You know why? So that you will know that the powder will be mixed with the water. Diserap, ya, diserap oleh water, the powder. Yeah. So that's why after you know that all the powder is what is clarut?
Dissolve.
I forget.
Dissolve,
yeah. Sorry. Dissolve in the water, then you just mix it. Ya. Diaduk seperti biasa. Ya. So and then you put it in the vibrator, yeah, so to remove the air bubbles. After you know that the air bubble is gone, then you can the mix, you can put it in the what's called it, the alginate. Yeah. Okay. So this one is the gypsum products. You can see here, this is the plaster of Paris, the white one, and usually they have a base here. To really know about the occlusions, to study about the occlusion, the condition of all the teeth, yeah, and usually for this is for the orthodontics study model. Yeah. For the dental stone like this, it is used for casting usually and make some for the prosthodontic denture. Yeah, this one also from the dental stone. The cast or master or working cast is the replica of the prepared teeth, ridge areas, and other parts of the dental arch. Yeah, but die is the positive reproductions of the prepared tooth and consists of a suitable hard substance of sufficient accuracy, usually an improved stone, resin, or metal. This is the die. Yeah, specifically reproduction of one tooth, we usually cut here and then we put some pin here so that it is easily removed for carving the crown if we would like to make a crown here with casting wax. Yeah, this one like this. Okay. So when I got your form B, then the learning objective that are not yet understood is these questions. First, what is the difference between the use of gypsum as dental plaster and dental stone? Anybody can answer this one now? Who can answer, please?
Can I try to answer?
Yes.
So for the type 2 or the dental plaster, it should be for the clear study of the teeth. And while for the type 3, it's for a working model for like carving the lane, bridge, and crown.
You mean the type 3 is the dental stone or the dental plaster?
Yes, the dental stone, bro.
Okay, that's right. Okay, so you now understand about this, but I hope that you will know all about the type of the gypsum, yeah? From 1, 2, 3 until 4, 5. Okay. Number 2, why isn't type 1 gypsum still used as an impression material for edentulous? Who can answer this?
Can I try it, bro?
Yes.
Is it because it's rigid and it's not elastic?
Yeah, it's rigid. Yeah, that's right. And also it is quite brittle. Yeah. So very light, but brittle. Yeah. So that's why we don't usually use it again, and it's really messy, yeah, something like that, messy, and it is better if we use the double impression or the elastic impression materials. Okay, thank you. Who answered it? Malachi?
Yes, bro.
Is that you? Okay. Number 3, types of gypsum and their use. I think you already know about this, yeah? For type 1, type 2, type 3, type 4, and type 5.
Can I try, bro?
Yes.
Oh, okay, sorry.
Okay, no, you go ahead.
Oh, okay. Can I answer, Prof, maybe?
Okay, Rehan?
Yes, that is correct.
Okay, Rehan?
So type 1 would be like the impression plaster.
Yes.
Type 2, it's like the plaster used for like making the model.
Yes.
Type 3 is
model for what?
Model for it's working.
No.
Or study. I forgot.
Yeah.
Study. Okay, study.
Just for
Study. Okay, study. Then type 3, dental stones just used for like the mounting material, and type 4 would be like the dental stone. So like for like height for like.
No, type 3 is the dental stone.
Oh, type 3 dental stone, yes.
Yeah, don't forget about this because we usually use this dental stone type 3, yeah, for working model,
Working
not
model,
study
okay.
model,
Okay.
because it is more expensive than the dental plaster. Okay, then type 4.
Type 4 is just like used to like high storage stones. I'm not sure for 4.
It's nearly the same with type 3, but the strength is higher. Yeah, sometimes.
So they're both dental stones.
Yes.
Okay.
The name type 3, 4, and 5, we call it dental stone, but with higher higher strength. And type 4 is with low expansion, and type 5 with higher expansion.
Okay.
Okay?
Okay.
Remember that, yeah?
Okay, thank you, Prof.
Number 4, the reaction in gypsum. Why does the temperature in gypsum become hot when we wait the gypsum until dry? Somebody can answer this one?
Can I try, Prof?
Yes, Malachi?
Is it because the chemical reaction between the sulfate and the biohydrate causes the reaction to release heat, and it causes the temperature to rise?
Yes, because the reaction is exothermic, so it will release the heat. And when we make or the calcination, we usually give heat, yeah, for the calcium dehydrate. So when we we mix with water for the crystallizations, it will release the heat again. Yeah. So this reaction is exothermic. So before you do something with the gypsum, so let the heat what you call it evolve, and then until it is cold, then we can use, then it is setting already. Yeah, the gypsum is set. Okay. Okay, we move on now. Oh, this is the comparison between dental stone and dental plaster. Yeah, so dental stone is more expensive than dental plaster. You can find the dental plaster, the white one, is very cheap. Yeah, and dental stone is very solid, strong, and the surface is hard. They have a surface hardness which is quite high, but the dental plaster is less strong and they have less hardness, yeah, than the dental stone. Dental stone is for diagnostic purposes and also complete and partial denture construction. Or we usually use it for wax carving, for maybe making an inlay or crown bridge. Yeah, so it should be very strong so that it can resist the abrasion from maybe from sharp instrument that we are using for carving. Yeah. But dental plaster is usually for study model or the base when you use the articulator. Yeah, but it is not for working model. Okay, in dental stone, the water powder ratio is 0.28 to 30, but dental plaster, they need more water, which is the water powder ratio is 0.45 to 50, yeah, because the particles is irregular and bigger than the dental stone. Dental stone, they have smaller particles, so they need less water to be mixed. Yeah, but dental stone is heavier, the density is higher than the dental plaster. Okay, the color, dental stone have soft color like blue, pink, yellow, or green, soft green, and the dental plaster is usually white color. So you will not mix when you see the dental plaster and the dental stone. Yeah, dental plaster is usually white. Okay, next. So if you have more time, you can study more and you can look for this theory of the gypsum manipulations, how to manipulate the mixing the gypsum, and try also to find out about the properties of the gypsum like setting time, viscosity, strength, hardness, abrasion resistance, detail reproductions, and the setting expansions. Okay? Because it relates to the properties of the gypsum product. Okay. Any questions until this? No? Okay. We move on to the dental wax. Okay. This dental wax, sorry, is usually a mixture of 2 or more waxes with other additives used in dentistry. Yeah, the composition is usually natural wax or synthetic wax from gum, fat, fatty acid, oil, resin, and pigments. The properties, they have a melting range, not a melting point, but melting range, because they have a lot of composition which have a melting temperature, different melting temperature. Usually they have thermal expansions. They can flow if given heat, and they have residual stress. Yeah. So if you give a stress, like if you bend a testing wax, yeah, there is a stress when you bend it. Yeah. And then if you put this wax into the water, so you can see in 24 hours the wax will open and will they will release the stress. They will release the stress and become sorry. They still have residual stress, so they will release the stress, and the bending is open again. Yeah, and they also have ductility, so you can use it if you give heat. The condition you make more like wire. Yeah, we can use it. So there is the properties of ductility. Okay, this is the synthetic wax used. It is artificially made with chemicals, but natural wax is derived from animals, plants, or oil. Okay, this one is the classification of the wax. Yeah. the component also of the wax, and you can read it then. X. I think you have recorded it, and I can give you also the PDF of the power of this lecture. Okay. This is the synthetic wax, yeah, from chemicals, natural wax from a plant or from animal, and usually they have a high molecular weight. Yeah. Okay. The more important is that you know about the classification of the dental wax. We have here the pattern wax, processing wax, and impression wax. Yeah. So the inlay casting base plate wax is usually used for patterns. The inlay and casting for pattern wax, but it is used for casting for metals. But base plate wax usually for acrylic resin. This is the base plate wax. Yeah. And then processing wax. When we do work with wax, sometimes we do boxing wax. It's I think this one is boxing wax. After you make an impression, then you put this wax, yeah, this boxing wax, so that we can cast the gypsum, and then we can have here the margins, which is more with the finish line that is very nice, yeah. Okay, and then we have here the sticky wax. Yeah, if we would like to align the fractured parts of the acrylic resin, and then we use this with the sticky wax, we heat it, and then we put in the part that is fractured, and we combine the other fractured part, and then it will be aligned, yeah, when the wax is set. And then we can do the reparation of the acrylic resin. Yeah, this is also the alter to the stock tray utility wax, when we would like to have a more detailed, like the vestibulum one of the jaw. Yeah. So we put it in the around the, let's call it the custom tray, when we would like to do the impression. Okay. This is the base plate wax. Yeah, usually it is layered to produce the contour of the denture and hold the position on which denture teeth are set. Yeah, something like this. You are going to use this one in the SL. Yeah, like this. And then after it is done like this, then you can put the arrange the teeth, yeah, the acrylic teeth, so that it in making removable denture. Next is the bite registration wax. Yeah, this registration wax, the shape is like our occlusion, so we put this wax in the mouth, in the occlusal of the teeth, and then we just bite this wax, so that we know the occlusion of the upper and lower teeth of your jaw. Yeah. So the learning objectives that are not yet understood is, the question is, are all types of waxes used for casting? Somebody can answer this one? Are all types of waxes can be used for casting?
No.
Nashwa? Can you
Yes,
answer
ma'am.
this one?
I don't think not all of them.
Yeah. So for using for casting, what wax do you use?
Is it the base plate?
No. I just told you the base plate wax is for making denture. Like this one, base plate wax. Yeah. For making a denture from acrylic resin, a removable denture. Yeah. So usually for casting, we usually use inlay wax and casting wax. Okay, Nashwa? So you must look at the theory again. Okay. Okay, this is a casting wax. Yeah, we have a lot of different shape here. Yeah, for the casting, and this is also the shape if we want to use this kind of shape for the removable denture, but for the frame denture with metals like this. Yeah, this is after casting. And also we can use the inlay wax. Yeah, this one is the inlay wax. If we would like to make a crown inlay, onlay, like this one. Yeah, this is inlay only. Like this one, we make with inlay wax. Yeah, and then the wax pattern, we use it with the sprue, like this, and the crucible for casting technique. Yeah, and this is the metal casting. Okay. Can you get this understanding?
Yes, Prof.
Okay. Okay, next. Oh, this is in the wax. Oh. Yeah, okay. From dental wax, I think I already give you some hints about it. Yeah, hope you understand and know the differences. Okay, next we are going to talk about the impression materials. So this is the ideal properties. Yeah, it should be comfortable with the odor and taste, and also the aesthetic color. You won't like to see when you are going to get an impression from your dentist with a color of maybe different or black or something like that. Yeah, it's not something that you would like to have in your mouth. Yeah, and also it should not be toxic or irritate the soft tissue of your mouth. Yeah, and they have an adequate shelf life. Yeah, and economically, not too much, not too expensive, and easy to use. Yeah, setting time. Adequate setting time for clinical use. Here the setting times is not very long or not too short. Yeah, but for clinical use is used properly. Yeah. They also have good consistency and texture, good weighting to oral tissue. They have elasticity, good shear strength. Yeah. and it means that the impression should not fracture or tear easily. Yeah, and dimensionally stable, compatible to gypsum, accurate, and can be disinfected, and there is no gas involved. Yeah. This is the classification of impression materials. These classifications is between the non-elastic and the elastic impression materials. Yeah, you can see that the non-elastic is the impression plaster. Yeah, from gypsum. There is also an impression compound, wax, and zinc oxide eugenol cement or impression materials. So this is non-elastic. It is a little bit of rigid one. Yeah, but the elastic one, we have two different this is not non-aqueous hydrocolloid is more than non-aqueous or elastomeric materials. Yeah, I think. Yeah, so aqueous, if we need water, is like agar, alginate, but if we don't use water, is usually the elastomeric impression materials such as polysulfide, polyphenol siloxane, silicone, polyether. Yeah. Okay, so you are going to use this classification. So all the impression materials that we have is like that: 1, 2, 3, 4. Alginate hydrocolloid and agar hydrocolloid. This one is also called the aqueous elastomeric impression materials. Yeah. And the elastomeric impression material is more like the elastic. Yeah, elastic impression material. You have polysulfide, condensation silicone, addition silicone or PVS, and polyether. Yeah, you can read it next after this. Yeah, so that you won't forget. Okay, and then we have the bite registration materials. Yeah, it's using the addition silicone or polyether, zinc oxide eugenol, wax registration, and impression compound. Yeah. It's only for the bite registration or the condition between the occlusion of your upper jaw and lower jaw. Yeah, the bite occlusion of the lower teeth and the upper teeth. Okay. This is what I advise you to know more and to find out more about impression materials. So you need to know about the composition and its function. Yeah. Also about the proper properties. Yeah, especially the different composition, they have different properties, and their accuracy and dimensional stability. Also the indication and contraindication and how to manipulate all these impression materials. Yeah, and also the specification. Okay, for the water for the ratio, usually in alginate, we have water plus powder, but we also for the elastomeric impression materials, we use the base and the catalyst in tubes to make a paste. Yeah. For For the hydrophilic properties, when they interact with water, including the ions and polar molecules. Okay, next, this is the alginate. You have already used it, last time. This is the excitable alginate impression for both the maxillar and mandibular impressions. So please, you have to know that it should be no distortions. If it breaks or there is when you make an impression, then you will see after removal, you will see the custom tray. It's not right. So the custom tray should not be exposed. And the alginate should be firmly attached to the tray. Because there is the retentions like the hole, for the retention of the alginate. Okay, all the retromolar area should be recorded. Also the hamular notch, in the upper, in the palate, in the upper jaw, and also the peripheral roll and the frenulum. Should have no whites or small bubble, and they should have a very good reproduction details of your mouth, like this one. So this one, it reproduced the vestibulum very nicely, and this one, the lingual wing in the lower jaw. This is the frenulum. It is also recorded. Okay. Then what factors that will affect the alginate setting time? Okay. Usually, yes.
The temperature of water.
Temperature of water, yes. First, the water-powder ratio, you already know. Water temperature. If you mix the alginate, if you use cold water, and it will prolong the setting time. Maybe if you use the normal setting time, usually it's about 3 to 4 minutes for setting, but it's for you to learn. It is too. There is no time for you because you're still learning. And sometimes we can use the ice, for the temperature to rise, and we use to mix the powder of the alginate with cold water, and the setting time will prolong. Okay, but the effect is not good for the patient. Why? Because it is too cold, and it is when you make an impression in the mouth, and with the cold alginate, then it will give sensitivity to the patient. But the setting time will prolong. Will be longer. Can you understand, Brian?
Yes, Prof.
Okay. And also the air temperature. It means also the humidity and also the temperature in the lab or in the clinic or the weather. Because it will be different in our tropical weather and the four-season weather in Europe or in the north area of the world. The humidity will give more contaminations of the powder, so the setting times usually is shorter. Okay, And then the other effect is the mixing method. If you mix it too long, yeah, or too short, then also it will affect the alginate setting time, because sometimes it's the mixture is not homogeneous, yeah, and also it will set quicker. Yeah. Also, if we have contaminations like there is some maybe contamination from oil, from other substances, yeah, it will also affect the setting time of the alginate. Okay. This is the concept of sol and gel in hydrocolloid. Yeah, you can have the sol, and then if when you mix the alginate with water, and then you have a viscose, you will have a condition of sol, and then it transforms to the gel condition. So it is elastic semi-solid. Yeah. And this is the gelation process. Yeah. With the chemical reaction, it will form a chain of dispersed phase, and it will interlock, and after that it will become a gel. Yeah. So this gelation process needs gelation time from mixing until it is placed in the mold. Yeah. So maybe it's also it is also called the working time until the setting time of the alginate. Yeah, the working time is usually 2 minutes, and then if it is a fast setting alginate, we need more 1 to 2 minutes for the setting time, and for normal setting time it needs 3 to 4 minutes to set. Yeah. If we would like to prolong a little bit of the setting time, we can add some more calcium sulfate or sodium phosphate as a retarder. Yeah. This is the elastomeric impression or elastic non-aqueous impression material. You have condensation silicone impression. This one is polyether. This one is polyphenol siloxane. This PVS, is the one that is very popular now, because they have a very good reproduction details. They should not be immediately poured with gypsum. Yeah, it can be delayed. Yeah, even 1 day. They will not. It is very stable. They will not expand or shrink. Yeah. So this PVS is usually very popular among dentists, but it is quite expensive. Yeah. This one is the polysulfate impression materials. Yeah. This one also is practical to use, but the patient doesn't like the odor of this impression material because of the sulfite. Yeah, the sulfite odor. Okay, this is the impression compound. We usually don't use this one, and especially when we still have teeth, but we can use it for jaw without teeth. Yeah, and this one is the polyether impression material, which have a good stability, dimension stability. Now, the learning objectives that are not yet understood. The question that you already asked is, you would like to know about the specific information about why we mix the alginate powder, like powder to water, not water to powder. Who can answer this one? Is it the same with the gypsum?
Yes,
No?
ma'am.
Yes?
You put the
Malachi?
powder. You put the powder into the water.
Yes, powder to the water. But we can also use the water to powder if we are already skilled. Yeah, even in my clinics, for the theory, we are going to use powder to water. But if we already skilled with this, then you can put the powder first, and then you can add some water.
Is it also to prevent clumping, Prof?
To prevent what?
Clumping.
Pumping.
Clumping.
What do you mean?
So it prevents clumps from forming when we put water into the powder. I mean, when we put powder.
Bubble, you mean?
Yes.
Yeah. Yes, that's right. And you have to mix it very careful at first time. Yeah, you mix it very slowly so that all the powder is mixed with the water, and then you can mix it more quicker with the press to the bowl. Yeah, to rotate and to press it in the bowl walls. Yeah, so that's how we do the manipulation. But if you are skilled, sometimes we don't do the proportioning. I mean, in the SL, you use you have to use the what's called it, the water. Let's see, glass ukur, yeah, and then you also do the scoop with the scoop of the manufacturer alginate, yeah. But sometimes if you are skilled or you can do it easily, sometimes we don't do the proportioning, but still we will have a very good mixture of the alginate. Yeah, this is come from experience and a lot of practice. Okay. Number 2, what are the factors that affect alginate hydrocolloid setting time? Why does different alginate have different setting time? Someone can answer this one? Zahra, can you answer this one?
Yes, I can. So the factors that affect alginate.
I cannot hear you.
Hello.
Yeah.
Okay. So the factors that affect the alginate hydrocolloid setting time are the water to powder ratio, the temperature of the water, and the air temperature as well, and the mixing method, the contamination, the humidity.
Okay. Yeah. And what about why does different algae have different setting time?
Because their composition reacts differently. Like they have different material and they react differently in exothermic reaction.
Yeah, because of the different compositions. Yeah, and all the manufacturers will have their own compositions and how to manipulate and also the proportion. So sometimes, if you use the alginate, you will have to know the instruction from the manufacturers. Yeah, if they said the portion or the water powder ratio 0. I don't know, one scoop with how many milliliters, then you have to follow the instructions. Okay, because the compositions is the secret from the manufacturer. Okay. Okay, thank you, Zara. Number 3, the specific differences between simultaneous method and dual viscosity method in dental impressions. Who can answer this one? Alia?
I'm actually asked the question, Prof, but I don't get the simultaneous method and dual viscosity method. So because it's written in the books, in the Sakaguchi books, it has the same meaning. So I would like to ask the specific differences between both of the methods.
So what do you think it means? Can you just guess maybe?
As I found that the dual viscosity have used for the thicker composition of dental impression materials, but I feel like the whole book explained like it's actually the same. It's not like the book doesn't mention about the difference about both of them, Prof.
You see here there is a dual viscosity, so there is 2 viscosity of the impression, right? And usually with different viscosity, we call it the heavy body and the light body. Yeah, the heavy body, it looks like the viscosity is very high. Yeah, so it looks like paste. Yeah, and then we use it to make an impression first. Yeah, without too much care in the accuracy, but we already got the condition of all the teeth in the mouth. And then after that, we remove it, and then we put some light bodies above this impression, yeah, with the heavy body. With the light body, the viscosity is very low, so it can flow. Yeah, and then after you put it in the tray, then you will make the impression again inside the mouth. Yeah, you will know that the lower viscosity will spread into the teeth. Yeah, and it will make a very good accurate impressions. Yeah, after setting, then you can remove it from the mouth, and you will have a condition like this. So, see, you can have the condition like this. This is very, very detailed. See, and you have 2 kinds of color here. the blue one and the pink one. So usually the blue one is the heavy body. Yeah, it's like this. Yeah, the paste. And then the lighter one is from the tube and will give very reproductive details of the condition of your teeth. Yeah, that's why it is also called double impression. They have two kinds of viscosity. Okay? And sometimes we do it simultaneously also. Okay?
Okay,
So,
thank you, Prof.
Alia, you can also try to find that not only in Sakaguchi, but other textbook. Okay?
Okay, thank you so much, Prof.
Okay, next. Oh, this is still the properties of the elastic impression materials. Yeah, you can see here the differences. Oh. See, there is the properties here, dimensional stability, hydrophobicity, hydrophilicity, volatile byproduct. Yeah. Usually, if there is no volatile byproduct, there is no byproduct, then usually the impression material is very stable. Yeah, like this PVS. It's very stable. The stability is very high. It is hydrophobic. Yeah, and because of that, it can also be delayed in pouring pouring the gypsum to the impression. Yeah, you can delay it. Maybe one day it's okay, but the accuracy is still very good. Yeah, and it is also called the addition silicone. You know now, the dentists usually like this addition silicone or PVS. Okay, this one polysulfate, it can shrink. Yeah, so the dimensional stability is lower, and it is hydrophobic also. And the byproduct, they usually have a byproduct of water. Yeah, a little bit of water. And if you make the impression after you remove it from the mouth, then you have to immediately pour the gypsum so that it will not it will have the most accurate condition of the tooth. If you delay it, then it will shrink. Yeah, so the accuracy will be decreased. Yeah, and the polysulfide, the other condition, it is least expensive, so it's quite affordable, but the odor of sulfate is not very pleasant. Yeah, the patients sometimes feel not comfortable with the odor. Yeah, and the setting time is too long. Yeah, condensation silicone also is not very popular because they have poor dimensional stability, and it also have a volatile byproduct of ethanol, and it should be poured immediately with the gypsum. Okay, polyether is really quite popular now, yeah, because the dimension stability is very high. But it is hydrophilic. So you are not supposed to have a contamination from the water. So that's why it should be very careful in using this polyether because of the saliva in the mouth. Yeah, and also it can be delayed from pouring the gypsum with still the accurate condition of the cast. Yeah. Okay, this is the double impression, yeah, that I have already explained to you. See, you make this first putty heavy body, yeah, like this, and then you make the impression. This one, they use the polyethylene spacer, yeah, like this. Then you get the impression, and after this, you put the light body, yeah, not too much, and then you impress again in the mouth. That's what we have. You know, the blue one is from this one, and the yellow one is from this one. Yeah, so you have a nice impression of the tooth. Yeah, this one is the vestibulum. The teeth is very in reproduction details. Yeah, very nice. Okay. Okay. Last one is the investment dental materials. Yeah, this is actually a ceramic materials. Yeah, like gypsum, it is also ceramic. Yeah, to form a mold into which a molten metal or alloy is cast and must withstand high temperature. Yeah, the mixture of the three types is the refractory materials, binder materials, and other chemicals. Yeah. Remember, the binder materials of the investment dental materials is the gypsum bonded, phosphate bonded, and silica bonded. Why? Because the gypsum bonded, if the binder is the gypsum, then usually it's for casting gold, for casting the alloys that is below 700 degrees C. Yeah, but you use the phosphate bonded or silica bonded if the metals need melting more than 700 C. Yeah, maybe 1000, 1500 degrees C. Then you will have to use the silica bonded or phosphate bonded. Okay. This is the investment material. It's like a powder, yeah, like gypsum. It is also usually used as a dental stone of type 5. Yeah, there. And we can use it, investment material, for using the loss technique, loss wax technique, yeah, to make a casting procedure. Yeah. This is the die. This is the wax pattern, the red one. And then you put it in a sprue base or crucible, like this with the sprue here. Yeah. And then you put the casting ring over here. Casting ring is with metal, and then after that you pour the casting ring with the investment. Yeah, the investment is like gypsum when we mix with water, and then we pour it inside this. Yeah, so the gray one is the investment material, and then after burnout, we can have this one is the wax is already gone after burning this crucible, this ring, yeah, and we have now a mold here, yeah, a mold here, and then we do the casting. We melt the alloys, and then with the centrifugal pressure, we make the casting and allow the melting noise to go inside the mold here. Yeah. So you can see the YouTube then like this. Yeah. This is when you use the investment materials. I think, let's know. I think I already give you. Kok gambarnya nggak ada ya? Yeah. So this is the conditions that we use in the lost wax technique. Yeah. Like you want to make a ring, gold ring, it's the same technique, something like that. Yeah. This is the requirement of the investment material. It is should be easily manipulated. They have a sufficient strength, yeah, stability at high temperature, sufficient expansion. Depends on the metals that we are going to use, and it is also should be beneficial for the casting temperature. With the casting temperature, should not have porosity. They should have porosity so that the gas will be allowed to evolve, and they have a smooth surface, easy to divestment. Easy to break it down after the casting procedure, and it is non-expensive. Yeah, so this one you have to find out more about this, the requirement, the composition, properties, manipulation, etc. Okay, any questions? Yes, Malachi?
No, I don't have a question.
Okay, so if you have a question, then you can ask me by email or in the chat. Yeah. And when is your exam? UTS? UTS-nya kapan ya? 26 April, Prof. April? Oh, still long. Okay, so you remember my lecture here. Sometimes I use this lecture for the exam, yeah, for the multiple choice for the exam. Okay, I will send the PDF through Brian. Okay,
Prof.
so you can ask this. Okay, thank you. So we'll see you next week. Yeah, next week.
Yes, next week.
Okay. Oh, sorry. Maybe next week I will. I try to give you the clarification for scenario 3, but I'm not sure because I have to go to Bandung. But if not, it will be in the next week. Yeah. But I will cover the scenario 3 and 4. Okay.
Okay.
Okay, please ask me if you need something because it will relate to the skills lab that you are going to do. Okay? Okay, thank you for your attentions and I hope to see you more in next week. Okay, bye.
Thank you so much, Prof.
Thank you so much, Prof.
Thank you, Prof.